So, we are some students from Team 2169, and we'll be talking about some of the LabVIEW stuff and how some of the new changes in the beta testing. So, I'm Luke Schiller, I'm captain of 2169.
I'm Mason Drafty, new head of programming.
I'm Ryan Zeller, sub-head of programming.
And I'm Mark Jokin, the head of electrical.
And Mark, we can't see it.
Mark.
There we go.
Hi. So, what is LabVIEW? LabVIEW is a graphical programming language, and it is the native language to the CRIO, which gives it many advantages to some of the other languages. It has an extremely fast learning curve because there's no messy syntax to it. Everything is drag and drop. And it's not drag and drop in the sense that everything's pre-built for you, but you can get down into the internals and actually change things that matter. So, one of the biggest things is the built-in WPI library, which is a toolkit that has pretty much everything you would need to get a robot running right out of the box. It gives you access to motors, sensors, pneumatics, everything you can think of. The syntax is self-explanatory. When you are writing a program and you mess up on something, in real time, if you try to run that program, it'll immediately tell you, there's a problem, here's where it is, this is what you can do to fix it.
And even as you're writing the program, if you try to stuff a string into an integer, it'll say, hey, what are you doing? You can't do that.
Exactly. So, some of the new features of LabVIEW 2011 or FRC 2012 is much faster code deployment. One of the things that means is, from when you click the button to deploy, it now takes 30 seconds to a minute to get onto the robot to run versus several minutes in the past. So programmers, no more sword fights. So the other new tool is the localized code tool. And what that means is, let's say this is your robot main, and if you look at it, we have moved some things around. We messed up when we wrote our code.
This is essentially how the worst possible spaghetti code that you can make out of this.
And in the past, if you were to click the clean up button, which is right there, what would happen is it would mess with everything. It would move these things around, it would move that box around, and really, any modules or areas you had set up, let's say drive up here, ARM code down here, and sensors over here, is just going to be totally thrown into whack. And they're just going to be merged into one. Now, if you select an area and click the cleanup button, what you'll get is just that area is modified, which is really nice because that lets you clean up each individual module while leaving the bigger picture alone. So really, the biggest strength we feel in LabVIEW is that there isn't any syntax to learn. Everything you do is pretty much self-explanatory because everything's color coordinated. You can't shove a process into a number, or you can't shove a global variable into a ref number, something like that. And what that means is that if you do mess up, it's fairly easy to find that mistake and correct it.
And then another nice thing about LabVIEW is that it comes built with any single tutorial that you want. In the splash screen, all you have to do is click tutorials, and it will go through whatever you would want to know. It has examples of how to use every single different thing they could ever want to use for their own.
So, the new 4-slot CRIO looks like this. The new changes are, if you notice, it's much smaller and lighter. And the biggest part about that is that shrink in size. Because we've seen robots whose electrical boards are not only taking up the entire horizontal plane of their robot, but they've even gone vertical, and they're just towering. And you really don't want your CRIO dangling on a wall. It just isn't ideal. And what that means is, with the new smaller CRIO, you have more space to keep things lower and also lower your center of gravity on your robot. The one new change, as far as putting modules into the CRIO, is that now there's a specific order where you go analog, digital, pneumatics, and then any other slot you want. So if you have a lot of pneumatics or a lot of sensors, you just slip another one of those modules into that fourth slot. And if you look at the specs of this new CRIO, it has a lot more RAM and flash memory available to you, as well as taking up much less power, which means if you can handle problems where when you throttle your drive, your CRIO drops because it goes below that 19 minimum volt, they've actually made it so the CRIO can stay alive on only 9 volts, which means that you won't have any problems dropping.
So, with the new 4-slot CRIO, there's also an update with the CRIO editing tool for LabVIEW.
On the bottom, I think Brian perhaps mentioned it, but the four-slot CRIO doesn't have any physical dip switches. Well, you might be wondering where they went, so they're on the bottom of the imaging tool. And that, if you plug in an 8-slot CRIO in there, that area will be grayed out. But on the right-hand side, you can see that there's a module diagram where it shows a picture of your CRIO and then what modules are plugged in where. It also alerts you if you have let's say you have a digital module plugged into an analog slot. It'll alert you and it'll tell you, oh, you should probably move this here and then put the analog back in there. So with the driver station, there's also you can view what the Kinect is seeing, and it will represent your body as a green skeleton. It'll look like a green stick man, basically. And on the bottom, you can also monitor the CPU usage of your 4-slot CRIO or your 8-slot CRIO, along with the packet loss between them, between your CRIO and your laptop, and the latency too.
As well as the battery voltage on your robot.
Yeah. Next.
All right, so one of the most interesting things in the beta test this year was the Microsoft Kinect. And in case you might not know, the Kinect is an interesting sensor that uses 2 optical cameras and an infrared camera to create essentially a 3-dimensional map of a skeletal image of something we're looking at. And essentially what that allows you to do is use various gesture controls to drive your robot. So if you want to lift up your arm and have a robot's arm lift up, you can do that now. So things to watch out for is that you want to be careful with thresholds. If you're using one of any of the pre-built digital values, so head on or head to the right or head to the left, you want to make sure that you stick away from that threshold between the two. Because if you're on that threshold, it's going to be alternating between the 2 of them. And if you're using that to control something important, then your robot can behave rather erratically. So you can modify the Kinect's SDK server if you want to, and you definitely want to know some C# if you're going to be doing that. However, you can have the option to just get to the raw skeletal data in the various programming languages, and we've actually provided a LabVIEW API that already takes care of that for you. And so we'll have that available after kickoff. And the way that it works is it offers you the ability to pick between 3 different points on your body, and it'll give you the angle between them. Or you can select 2 points on the body, and it'll give you the distance between them.
So 2 things, guys. When you point at the screen, it's hard for them to see on it. So try to refer to the things on the screen.
Yep.
Then there was a question about what is hysteresis. What about hysteresis?
Where are they referencing it from?
I don't know. HYS.
I'm not sure how this applies to this.
Built into the Kinect server.
I don't have any experience with that, and so I think that it takes care of it. Actually, yeah. So actually, at this point, we have a video of us operating one of our robots using the Kinect, and we aren't going to stream it over this just because it isn't going to be a very smooth feedback here. So I believe we are going to post a link to the YouTube video of it in the chat if you feel like watching it.
Correct.
And then we also will be playing it up here so that we can commentate.
So for those of you who are on the video, are on this meeting, you can download the video or watch it on YouTube. I put the link up there earlier. I'll copy it, paste it in there again. You can also download it from the paperclip in the upper right-hand corner, in the upper part of your window there, and you can watch it that way as well.
So if we want to, could we play it
Yes,
on?
I'm going to play it up there. Why not play for YouTube? Real video.
Alright, so what this video is it's an example of us operating our 2011 robot, which had an articulating arm, using the Kinect. And the way that we had it set up was So this arm would control the first joint articulation, and the left arm would control the second joint articulation. And then the head to the left Boolean value would determine whether or not the claw that was used for gripping the two game pieces was open or closed. So as you can see, it's a very intuitive system. All you have to do is lift up your arm and throw it up, lift up its own hip. And so there's that threshold that I was talking about where it's going to jerk back and forth between the two different states. And one thing that you saw there is that you want to make sure that you remain parallel to, or perpendicular to the Kinect, otherwise it starts to return null values, and if you're using that to control something, that get a little irritating.
Talk about the screen behind you.
Yep. You also want to make sure that, if possible, you have a flat screen or a different flat object behind you, because if you are behind some really curved surface or with a lot of weird indents in it, it's just going to give you a ton of weird values, and you're not going to get very good success.
One other thing you want to make sure of is that when you are driving with the Kinect, you are the only person in the frame. Because if you have you driving it and Mason walks behind you while driving it, it'll see two people, but it won't necessarily know which one to track. So it could start taking Mason's arm, thinking it's my arm, and then bad things happen because now I have no control of the robot.
Yeah, just make sure that everyone else stays out of frame when you're driving your robot. Another thing that was new in parts this year was the Jaguar. Well, the Jaguar.
There's a question, or I'm sorry. During competitions, drivers stand rather close together. Did you have any problems with Kinect recognizing discrete individuals?
That's actually what Ryan just talked about. You do need to keep people separate, and we'd imagine when they give us the setup of the game this year, they'll have something to compensate for that.
Luke, before you move on, talk about what you think the Kinect might be used for this year.
Alright, so this year, it might not be the actual driver, per se, who's using the Kinect. It's also, one of our speculations is that the human player will be involved with the Kinect this year.
Okay. So the final piece we've got for your beta equipment is the new Jaguar that they did this year. From the outside, you can tell it looks the same. But the main new features they've got this year is what's called an auto ramp feature, which influences how it powers up and allows it to maintain use a higher voltage more effectively without tripping some of the safeguards in the Jaguar, which can shut down whatever's running or whatever the motor's running. They've also improved the CAN network. Last year, the CAN network, for those of you who don't know, uses these jacks right here and allows you to export the processing power from your CRIO to the mini processors inside the Jaguars. However, this function in the past has not been reliable. Last year's actually the first year that it's been really something that was just not filled with errors. And our team personally feels like it's unnecessary, as the CRIO is incredibly powerful. It's really not needed to move that processing somewhere else. The other thing it's got is a coast break option, which you can control in the programming. That affects.
It isn't controlled in the program. The coast break option is determined by this jumper here. So you want to make sure that you know which setting you have it in, and that you have it in the same setting for different ones controlling different modules.
For those of you who can't see, that's referring to the line of jumpers down on the bottom of the CRIO. One of the things I added is the coast break option, which affects how the motor functions when you're not giving it power, or not telling it to drive. As the names imply, if you can either select coast, which makes it so that it's just free flowing and the motor will shift back and forth when something else puts pressure on it, or you can break it and it'll lock down, preventing it from moving until you give it further instructions.
Alright, so just a clarification on that, is that under program control or is that only under jumper control?
That is controlled by the jumper on the Jaguar.
Talk about the spike.
Oh, they also introduced a dual spike this year. It's practically two spikes combined into one. it takes 2 amps right here, both 20 amps as it has labeled, and then 2 input or 1 power input, 2 PWMs to control each of the corresponding outputs.
How's the availability of that?
We're actually not sure if that's going to be in the parts this year. We don't really, they haven't released that information yet, so we'll just have to wait until January 7th to see that.
With the Kinect, they ask, do you get skeletal data, or do you get just discrete values?
The Kinect, it gives you a set of skeletal data points. So it will give you for each of your discrete body points, such as shoulder right, shoulder left, head center, wrist, all of those other different options. It will give you 3-dimensional values relative, Cartesian values relative to the Kinect.
And then also, somebody mentioned that there's some discrete some default gestures that are available. Do you guys know what those default gestures are?
Yes, there are some default gestures available, which we think about earlier. And so what some of those are, they include using the arms as joysticks, or very simple Boolean values such as the head to the left and the head to the right, and also different leg options. But don't use those too much in my follower.
Last question I have here is, has coast and brake changed from previous years? That jumper has always been at a set.
My understanding is that in past years, the jumper was there, however, it was not recommended that you use it. And in this year, it is now full supported.
I have unmuted the audience. If you guys have further questions, please unmute yourself and ask the question. Somebody typing here.
So how big is the threshold? So you mentioned like you tilt your head back and forth, right?
The threshold is probably about just a 5-degree range. You just want to try to make sure that you stick away from that, those 5 degrees.
Did you work with 3D control?
Yes, one thing that you definitely want to do is to make sure that when you're using the Kinect, don't feel constrained to just 2D plane. When you start to go into the 3rd dimension, you can unlock it. You exponentially increase the different amount of possibilities that you can use when you're driving.
Somebody asked, what Boolean gestures are there?
I don't have the entire list memorized, but some of them include things such as head to the right, head to the left, head forwards, head back. And you can actually make your own using the different APIs available. Yet there also are various leg and arms that are pre-programmed.
You're going to explain how you might see this being used in this year's game. Went on top. Well, what do you think potentially it might be used for?
My personal opinion, and we don't know any more than you guys do about what this is going to be used for, is that it's going to be used by the human player to have a similar control as the hybrid period in 2008, where the driver had a small infrared remote where they could send various signals to the robots.
We don't feel that it's necessarily accurate enough to completely replace driver control, which is why we think that it's more likely going to be some combination of driver control with autonomous.
Will we be able to update the firmware on our current black Jaguars?
Yes, you can. If you have a serial port, I believe that there will be a download for the new firmware, and you can put the new firmware onto your old black Jaguars, and it will work just like the ones.
And I think this one might have been answered, but they asked it just came up. How macro do the gestures need to be in? I.e., how precise or accurate are values?
Yeah, good question.
How macro do the gestures need to be? How precise or accurate are the values?
That really depends on what you're using it for. If you're using it for something like picking up a eyedropper with a precious liquid in it, then you're going to want to use pretty large gestures with a very large range of values. However, in general, it will be accurate enough for driving most of your applications.
Mark, you have a question?
My question is the same thing. Is there a specification on it, like angular accuracy? Is it 1 degree, 2 degrees, 5 degrees? And same in the Z plane, coming out, is there some measure relative to the space that you're looking at? Is it 5% of the space, 10% of the space that it's accurate?
I think with our API, we can get it down to within 2 degrees, right?
Pretty much.
Really, you're not limited by the software at that point. You're limited by how accurate the Kinect is, because it only has so many three-dimensional points to seize. So what you're limited by is can the Kinect itself distinguish this from this? And I personally don't know the answer to that. I know the predefined gestures give you a range from 0 to 100, and I'm not sure what the resolution on that is.
Somebody asked what language to use to program the Kinect.
You can use to program the Kinect, you can use any of the 3 languages available, C++, Java, or LabVIEW. If you want to modify the Kinect server SDK, you will use C# to do that. However, within each of the programs, you have the tools that you need to access the skeletal data and do whatever derivations of that information you need to.
What is the easiest?
What is the easiest one?
Depends on what you know best, right?
This is what you're used to. That would be the easiest.
Oh, the easiest. I see what
So do you see the Kinect as being highly valuable this year?
Extremely.
Is it hard to learn?
No, the Kinect is extremely easy to learn. The built-in classes allow you to use it just like you would with any of the other joysticks. You don't need to do any actual programming if you don't want to. And as I said before, for LabVIEW, we've provided an API that will allow you to get into the more nitty-gritty stuff if you want to.
Talk about the training seminar we're hoping to put on here at the Microsoft Technology Center. You know about that? Yep.
We have a representative from Microsoft who is going to teach some of us FRC teams about different ways to use the Kinect and hopefully give us a more in-depth knowledge of how to take full use of its potential.
Well, when will you get information out? I know I'll be that question.
We're putting that together. Tell them, watch your emails. We hope to have it out within the next couple of weeks, but this is something that we are working on, and we're very grateful to Microsoft for helping us all out here. So hopefully we'll have an announcement on that in the next couple of weeks.
Any other questions?
One more is coming up here. Did you guys come up with any reasonable way to use the audio input?
We didn't really consider that option, primarily because at competitions, it's going to be so loud that the audio input is not going to be worth using.
The youngest member on your team screaming. Here we go.
One other one. Coming up. See if we're typing it now. Oh, thanks for the info on Kinect. All right. Great. Thank you, guys.